review. So inshallah by Thursday is going to be the last review session inshallah we have. Alright, so we stopped it there last time. We were talking about the idea of polymorphism and how can methods be overridden in general. So if you remember, we ended it with this example. We had two classes and okay, there are two classes. First one is class A, second one is class B that extends class A. We have here the main method that has these two objects created. And I call here for the M1 method through A as an object and through B as an object. I'll give you multiple scenarios, but let's start with this one here. Alright, we have one instance created of class A type and the constructor of class A as well. The second one is of class A type but constructor of class B. So what do you think would be printed here by the first statement? Is it 1 or 2?
Oh, 1.
And the second?
2.
2. Nice. What if I made a change? So what if I... What if I made a change here, making this one private? What's going to happen?
1.
You will get 1?
Yes.
Okay, this one you will print 1 and this one?
It's going to be
Error. Okay. Like, let me start without having this one. And that's my main focus. What is going to be the output of this statement? Again, this is private. This is not there. And you only have this statement. Ignore this, okay?
Yes.
Error.
Yeah.
Okay, why error?
Certainly, because we can.
Because it's private, and we agreed private is only accessible within the same class. Very good. So this is going to be an error, the first case. Nice. What if I made it B? Hmm? So B equal new B. So the instance now is created of class B type.
Yeah, 2.
Error. 2.
Who's saying 2? Who's saying error?
He said
Error, hands up. 2, hands up. And the rest, what do you say? Okay. That's again an error. Okay? So again, you can't attempt to use any instance if it's private outside its own class scope. So even if this one is still built of B class type, it's still a member of class A. So you can't attempt to use it outside. So again, this is an error. Now assume like I keep this A as it was, okay? And I add this now.
And it's still type A, or is it type B now?
Type A.
Type A, then
Yes.
1.
Then error or 1?
1.
Or 2? Okay, if you say a number, tell me why, okay? If you say error, again, justify. Yes?
1.
You say 1. Why?
Because we're making it of the object A.
Okay, we start with, again, remember, recall back the concept we addressed last time.
Override.
What is that?
Overriding.
It's entirely overriding, true, but again, we have to follow what? A chain of request. We start with the first priority with the child. What if you don't find this in the child? You go search for the parent. Is it there in the parent?
Yes.
Huh?
Yes.
It's there. How about the way of like accessing it.
Oh.
So this is default, right?
Yeah.
Is default accessible within the same class?
Yes.
So this is fine, so it's gonna print for you in that case.
Okay.
1. What if this one again was private?
Also one.
Also 1?
Yeah, no.
Huh, we have 1, 2 errors still.
It's within the same class.
Yeah, it's within the same class.
Both are private, yes.
We can say it's one. It's the same class.
Yeah, it's in the same
Huh, 1 or error. Now this is again 1 because again, this is now accessible within the same class. Well done, excellent. Here? Okay. Now polymorphism is where we apply the concept of method overriding. So we can still have generic implementation, but again, this can be re-enhanced and re-implemented differently in every child class. So if I have, let's say, sound that's here in the parent class, I know that each of these animals will have different sounds, so the implementation is going to be different. Okay, let's look at this example, and let me annotate a few. So this is 1, 2, 3, 4. Okay? Now we have our main class, our main method, sorry. We start from here. We have 4 objects created. Each of them is of a certain class type. I'm trying to access the sound method every time using a different object. Just tell me 1, 2, 3, or 4. Let's start with this one. You say? 1, okay. How about the second?
3.
Excellent. How about this?
4.
Very good.
2.
How about this? Nice. Clear? Okay. Till now it's straightforward. Now let's move forecasting. So we agreed last time we have something we know as wide casting and narrow casting. Or maybe you've taken it as implicit and explicit casting. It's the same idea. So again, I have a big container and a small container. Will this one fit here?
Yes.
Yes. Will this one fit here?
No.
So again, we can insert, let's say, an int inside double. But I can't do the opposite way around. Right?
Yes.
Same apply here for objects. So how can I tell that this object is bigger than the other object? So I know, for example, human and employee. I have these 2 classes. Which one makes sense to be saved as another type?
Here, employee.
Do I save human as an employee?
No.
Do I save employee as a human?
Yes.
So I can say that all employees are human,
Yes.
but I can't say that all humans are
Employees.
employees. Very good. So will that work with semantics? Okay, I have 2 other classes, A and B.
We can.
Can I save A inside B? Can you tell?
Maybe. We can't.
I can tell.
Sorry.
We
Again,
can't.
what's the question?
Depending on which is superclass.
Depending on which one is the superclass. And how do you know which one is the superclass?
If it's extends.
Based on the extents. Exactly. So this defines for you the hierarchy. Once you have a clear picture, then you can tell if you can say the sub-child or the subclass inside the superclass, this is fine, but the opposite way around would require some work. So we can't save double inside an int directly, right? But I can enforce it. We call this process casting. Okay. So will this work here? You can tell me. So I have 2 classes, fruit and apple. And apple here extends fruit. And I'm trying to create an apple instance of class apple. And I try to save this object inside the fruit class.
It works.
Yes, that
It
works.
works.
This would work. Yeah?
Yeah.
Okay. So we call this implicit casting.
Free.
Now the opposite case will not be possible. Okay. So I have to cast it, so before saving, let's say, a person object inside employee, I have to downcast it first into employee instance. This is not much preferred, especially when you have objects storing lots of data and attributes. This might lead to somehow cutting off some of these data, and it might not perform as expected later. But in general, if you want to double check if this could be an instance of another class type, then this is how you can verify with an if statement. This can return for you true or false, and based on this, you decide whether to cast or not. So if this return it true, if it's an instance, then fine, you don't need casting. But if this return it false, then you will need to downcast. So in general, how would we compare objects?
Compared to methods.
Compared to, nice.
Equal to.
Equals, okay, nice. We have also,
Uppercase, lowercase. No, uppercase.
okay. There is actually case,
Yeah, I know, but it's
ignore
not
case.
for objects. Yeah?
It works, strings are objects, right? So it works for objects. Okay, and I also have the normal equal. We'll just learn the difference between these three for now. Equal as a method, and also the compare to. Now let's imagine that I have this guy here that police is searching for, and this guy has two locations, two houses that he owns. One in Mexico, the other in Canada. Now the policeman came into the first house, okay, and asked, is there someone called Jack who's actually owning this place? And the answer he received was yes. Same for the other house here. He went back to Canada, and people also told him that, okay, there is someone called Jack who owns this place. Now, is that enough evidence for you to tell that this is the same Jack?
No.
No, it could be another person, right? Now, if I'm here to say, okay, so I can't say that equal doesn't necessarily decide much about the location. So it looks mostly into the value itself, right? If it matches, then fine. But it doesn't go and check for the location itself. Now, if we try to insist and know more about the shape, let's say, or the height, or the age, even verify with the picture, is that the same person? And then I got yes from the first guy, and again another yes from the second guy. Is that now enough to tell that this is the same person?
Maybe.
Yes. So now this is what the equals actually make. It will try to verify not only value, but also the location behind, right? Now if I try, okay. So I have here two objects, C1 and C2, okay? Ideally speaking, when you create an object the first time, they are assigned a space in memory, right? So they could be a replicate. I have two people twin, okay? So they look the same, they hold the same values, they hold the same features, but their location is different, yes? That's exactly the same case here. If I try to go over the first statement, equal, will that return true or false?
False.
That's false. So it is the same exact value, but different location. What if I try to customize my own equal? So this is not the built-in one, okay? Here, this is one that I made myself, and I try to compare the value of radius of the first one with the radius of the second one. Here, I'm only using the default no arguments. So both will have the same default, right? So value-wise, the first radius and second radius. If the first one is, let's say, 0, and the second one is 0 as well, would that be equal? Would that return true? That's going to be true. So again, when you compare objects, you don't only compare the value, you also compare locations, right? That's why the first one returned false. Yes, please.
Why C1 double equals C2 as a false?
This one, right? Okay. So let's just, what's your name again? Taif. Okay, Taif. Let's assume like you're having a twin, okay? Same exact face, same exact features. So I can't really tell if you are two different people. So I can tell that you both hold the same name, let's assume, okay? you have the same height, you have the same, I don't know, skin tone, everything is perfectly the same, okay? So I can tell that you are one person or two people. Two people, why? Because you have your own existence that's completely different from the other person, right? That's the same case with these two objects. So these two objects were created, they hold the same features. So they hold the same exact value for the radius, right? But again, the first object, C1 here, has its own place in memory, yes? And then came in another object, I call it C2. This other object has the same radius value, but also has its own space in memory, right? Now comparing these two objects together, you will say, okay, they hold the same value, right? But their location in memory is different, right? Now compare to, can return what type of values?
True or false?
Zero,
Negative one.
zero, negative value, positive value, not necessarily one, right? So this depends on the difference between the two letters, let's say, that you are checking for. We call back ASCII code. Remember this one?
Yes.
ASCII chart? Without even knowing the value. If I'm trying to compare A to B, how many places of difference you see between?
One.
It's only one, right? So this will be either a 1 or -1 based on which one comes first. If I compare A first, this is negative or positive?
Negative.
That's negative, exactly. If I bring B first, this is positive, right? So as you progress down in the ASCII code, the value actually increases. Let's assume I'm comparing A to C.
Negative.
Positive what?
Two.
2. So I'm talking now about a base of 2 between the two letters. Excellent. So either -2 or plus 2.
2.
Excellent. And if it's exactly the same, if I'm comparing A to A,
0.
this is 0. So 0 indicates same value. Negative value indicates less, right? Positive value indicates high. Very good.
طب what if إذا كانت كلمة مو حرف؟
It's very interesting. Now it will go with the first match. Okay, so it will, for example, first letter here is A and A. It skips this one. Then it goes to the second one. With the first variance that you match, the value will be calculated. That's a very good question. Now, type of inheritance. We have 4 types of inheritance. Were you aware? So what do you know about inheritance? I'm pretty sure you covered lots of languages. Python, Java, of course. What else? Not yet. Okay, cool. We have other languages, and the rules of inheritance in general is different from one to another. So, what do you know about inheritance for now? Or what type of inheritance you're aware of?
A superclass and subclass.
Superclass to subclass. Okay. Like, can I ask you a question?
Yes.
Let me actually draw for you some scenarios. You tell me if this is there or not. What do we call it? Do you know the name of this inheritance?
Subclass.
Single.
Inheritance.
Single inheritance, right? How about this one?
Double.
Is that supported? So we said this one is supported. This one? What do we call it? Multi-level. And again, this is supported. How about this one? Is it supported?
No.
Okay. So I can have 2 subclasses, 1 parent. Yeah?
Yes.
We call this hierarchical. Right? So this is hierarchical. And this is again supported. Okay, how about this one?
Double inheritance.
Supported?
No.
No, supported. That's not supported only in Java. In other languages like in C, you can see that this is actually there. We call this multiple inheritance. It's not directly supported in Java, but there is a twist. Do you remember? Interfaces, thank you. So the level of abstraction can actually achieve this. We'll talk about this in a while. So this is just the same. Okay, now let's talk a little bit about the abstraction. So we have two classes here. One that's a parent and the other is a child. I can extend an abstract class. Can I inherit still from it? Yeah, it works. So you treat abstract classes like normal classes. What do you have? What are the members of abstract classes here? What do we include inside? Can I add variables?
Yes.
Yes. Can I add implemented methods? No? Okay, can I add abstract methods?
Yes.
Actually, you can add implemented and abstract methods. Alright, implemented methods are just like you put a header, you can have a full implementation as you wish. Now the abstract method on the other side has a header, but then you plug this with a semicolon. We don't have braces, we don't have any implementation inside. So these two are part of an abstract class. We can have both of them. Then I have here a trick. So every time you specify a method to be just a header, you need to add the keyword abstract to it, right? This gives an indication to the compiler that this is missing, okay? This is not implemented yet. So who takes the responsibility of implementing it? The child. That's why we classify the child to be of two different types. Okay, so I can have it abstract or concrete, okay? When do we say the child is concrete? So concrete is not a keyword, by the way, but it's a title that you will give for a class that fulfill the implementation of all abstract methods of its own parent, okay? So if here I have two methods, both are abstract, and if this one here implements both, then this is concrete class. It's complete now, okay? If I don't have any of these methods implemented, just one, this is now considered abstract, okay? An abstract needs to be, again, throwing the responsibility on a subchild.
And in that case, do we need to add the abstract keyword?
Yes, of course.
Okay.
In that case, you need to clarify that this class is still abstract.
Yeah.
And there should be another class inheriting from dog and implementing this method, okay? Okay. So this is actually the difference between both. Here I have two methods, and this class here implements only one of them. That's why I gave that abstract keyword. This one implements both, and that's why I don't need any abstract keyword. I cannot instantiate an abstract class, so I can't create an object of abstract class type. So this is not possible, but I can still do it if I'm relying on a constructor of a concrete class. Or let's say an entire use of a class and a constructor that's concrete. All right, you tell me, what's the problem here?
You said the abstract keyword not present in the method.
Excellent. This is now missing. Alright, now we have this example. Now what's the issue?
The age of abstract.
Age is what?
It has no abstract.
Age has no abstract? What do you mean? Yes.
I think the issue is that when we need a non-abstract method, we're not supposed to put anything in the body of it. We leave that for the concrete class coming after.
Again, which method you're talking about?
This one here.
Here, this
Public
class.
void age,
This one, okay.
yeah. We put something in the body of the method.
Yes. So we said abstract classes could have either abstract methods or
Non-abstract.
implemented. This is just a normally implemented method, right? And here you're only overriding it
The
for that
public
child.
modifier.
Hmm?
Can we have a public modifier for an abstract?
We need public modifier.
I mean, can we have a public modifier for an abstract?
Yes, but no.
Shouldn't the second class have the keyword abstract? as well?
Why is that?
Because we didn't use the method food.
Excellent. Your name again?
Sarah.
Sarah? Thank you, well done. Yes, so here we're implementing sound, which here used to be abstract, but we're not implementing food, right? This is now missing here, so I need to declare this class to be abstract or implemented, right? So these are two possible fixes. Alright. Now let's have an example where you see abstraction, inheritance, and polymorphism. Where do you see abstraction? Class animal
Yes.
is declared to be abstract. Where do you see inheritance? Class cat and class dog. They're both extending from animal, right? Where do you see polymorphism?
The main, the public, main. For
All the classes?
All
Which
classes.
classes?
Animal or dog.
Where?
or
Which
cat.
part?
The sound.
The sound method. Now here this is overriding these methods to implement this differently. Perfect. Who can tell me the output now? Let's call it something, okay. Let's call this 1, sorry, 2, 3. First one,
2,
second,
4,
1 or
oh,
3.
3, 3.
You agree? Okay. So again, interfaces simply use the implements keyword, and it's one nice application of multiple inheritance that's not usually supported in Java. So they do achieve abstraction, they achieve the goal of multiple inheritance, and they enable you to have loosely coupled implementation, so a component is not necessarily controlling other components in your code.
Doctor, didn't we say that's not supported?
It's not supported, true. But here, this is not actually a class, so this is interface, right? And that's a very common trick, actually, you will see with developers. Interfaces were meant for a purpose. They are descriptive. They describe something. I can say the food is edible, right? I don't know, the light is measurable. So just something that you can somehow describe. What you will see in the actual life of development, they treat interfaces like classes. It's very limited, but they are using it mostly to, okay, so I can have this an interface, and this interface is implemented by class. This as an interface, and this interface is implemented by class. Now this class is implementing these two, so it's as if this class is actually implementing these two classes, right? So I can have one, let's say, for student, one for faculty, and it's doing the job, right? So that's indirect walkthrough, that's it. But eventually, this is still an interface, this is still an interface, and there is another nice trick here that you can have interface inheriting from two other interfaces. So it can help you a lot with splitting the logic as you go through the application itself. Again, we cannot instantiate interfaces. And, okay, can I extend and implement at the same time? So I can say class B extends A, implements C, right? This would work. Okay, so this is actually how it goes. We usually put constants and abstract methods only inside interfaces. Since they have to be abstract by default, there's no actual need to add the abstract keyword. So even if you don't put it, it's still considered fine. That's one common trait between interfaces and abstract classes. All right, we can tell me the output here. So I have here how to eat method declared inside this interface, no implementation, and also no abstract keyword. Do you think this is going to cause an issue?
No.
So this is now fine. How about this one? What's going to be printed? So this is going to call this directly. Again, this is implementing edible. If this wasn't there, what's going to happen? Syntax error. All right, this one. As we said, no smartphones in class. Okay, let's look at this one. We said we have an interface. We have two classes, right? One has the main method, and the other here has the how to eat method. Again, this is just an instantiation of this object and also a call for the how to eat method. Again, this is how it's declared. No implementation, but this is how it was implemented since this class here implements edible interface. So there's a nice trick here. I'm not sure if you noticed that. If I have two classes, this one has any attribute like age. How can this class use this one?
Fine.
Hmm?
Define.
No. So we're not talking about constants. That's a normal variable. So one class wants to use a member of another class.
Can you say it louder?
Okay, I have here two classes, A and B. B here needs to use age that's declared in the A class. How can I do it? Implements. So these are two classes. Do we implement?
Yeah,
We can inherit.
extend,
We can inherit without inheritance. Let's assume without inheritance.
Age is a variable. Age is a variable or method?
Age is an attribute. We did this a lot actually. Like when you have a main method, and this main method is trying to access age.
We call it from main.
Hmm?
We call it from main.
We call it from main. How? A constructor. So I need to create first an object, right? So I would say A, for example, equal new A, right? Then A dot age, right? Now, do you see what happens between these two? I have here calories. Simple direct call, as if you see it part of your own class. So again, this is one nice trick for interfaces. Again, once you implement an interface, it became part of this class. So anything that's listed here is fully visible, okay? Okay, you can tell me the output. Is there any error here when this is empty?
No.
Even if it implements edible?
Yes.
Okay. So is there anything that seems off? So I have how to eat here. It's
Does it have to have the method?
that's my question. Do I have to have here how to eat?
I mean, it's void, so.
It's void. What do you mean it's void?
Like, do we? I don't think we have to have something in the body.
This one?
Yeah, the abstract class.
Yeah, because that's an abstract class. Thank you. Very good. Yes. It is abstract. So when you declare this to be abstract, you mean, okay, I'm not interested in implementing it. Let my child do it. Okay? Now the child actually has the implementation. If this wasn't there, again, syntax error. All right, so now this one here, will it call this or this? Why? Because that again gets into that class and it will simply print this. The second one will print the other one in the apple class, right? So now this is how I can do it for multiple interfaces. I can just say this class implements the first interface and the second interface. I think I'll stop it here. We're still left with a very small part, it takes only 5 minutes. We'll keep this for Thursday class with the last part of our review, inshallah. Do you have any questions on today's session?
No.
You all good?
Yes.